In these problems, we're working on factoring out the greatest common factor from an algebraic expression. What are we doing actually when we factor out a greatest common factor? What we're trying to do is find something that we can divide each of the terms by and pull it out. So in the end, we'll have a set of parentheses with two terms, some term here in the middle, and our factor that we've pulled out right out here. So that if you multiplied it back in, you'd get what you started with. So what I want to do here is look for what I can divide both of these terms by, the biggest thing I can divide both of these terms by, and I'll do it piece by piece. I'll start with the number, then look at the x's, the y's, and then the z's. So let's set this up. I do want a big set of parentheses for what's left over here, and there are two terms separated by a minus sign, so I'm just going to put the minus sign right in there. And then out here, I'll build up my greatest common factor. Let's look at the numbers first. We have 21 and 28. They're both divisible by 7. This is 7 times 3. This is 7 times 4. I don't think they have any other common factor, so I think 7 is the biggest common factor. So I'm going to choose to divide both of these terms by 7. When I do that, I put the 7 out here. So there's my 7. And 21 divided by 7 is 3. And 28 divided by 7 is 4. So that's what's left over after I do the dividing by 7. All right, we've done the number part. Let's do the x part. Here I have x to the third, and here I have x to the fifth. The greatest common factor between them is 3 x's multiplied by each other, and x to the third. I could divide this side by x to the third, or this term, and I could divide this term by x to the third. So that's what I'm going to pull out, x to the third. When I divide by x to the third here, it just leaves a 1, and since we're multiplying here, we don't even have to write it. Here, if I divide x to the fifth by x to the third, I have to subtract exponents. 5 minus 3 is 2. That leaves x squared here. And here I didn't write anything. I could write times 1, but 3 times 1 is still just 3, so I'm not writing that. All right, let's go on to the y's. Here we have y to the third, and here we have y to the second. The biggest thing they have in common is y to the second. So I'll divide both by y to the second. So I put that out here. So y to the third divided by y to the second just leaves y to the first power. And here, y to the second divided by y to the second is 1. And again, because we're multiplying, I don't need to even write it. And then we have z to the second and z to the second. The biggest thing they have in common is z to the second. So that's what I pull out here. And that just leaves a 1 and a 1 here. So I've actually completed this. I'll rewrite it so that the spacing looks nicer. 7x to the third, y to the second, z to the second, times 3y minus 4x squared. Now, if you were to take this piece and multiply it by each of those two terms, you should get where we started. And that's a way to check to see if you've done it right. Let's try it one more, a little bit trickier. This is it's just got more terms here. You can see there's 1, 2, 3, 4 different terms. So this is going to be quite a big one. So I'll make a big set of parentheses here. And let's see, I've got one term and then a minus sign, and then a plus sign, and then a plus sign. I don't know if I left enough room there. We might be squished. All right, let's give it a try though. So for the numbers, I've got 35, 15, 15, 20. Looks like they're all divisible by 5. So I think I'll try that. So 35 divided by 5 is 7. 15 divided by 5 is 3. 15 divided by 5 is 3. And 20 divided by 5 is 4. Okay? Let's go on to the x's. We have x to the third, x to the second, x to the fifth, x to the second. The biggest one they all have in common is x to the second. Really, you're always looking for the smallest power of x, because that's the biggest thing you can divide each of them by. So x to the second goes out here, and we divide each term by that. So x to the third divided by x to the second in the first term just leaves x. Here it becomes a 1, so I won't even write it. Here, x to the fifth divided by x to the second leaves x to the third. And here, x to the second just divided by x to the second just becomes 1, so I won't write that either. All right, we've done the number and the x's. Let's do the y's. We've got y to the fifth, y to the fourth, y to the eighth, y to the fourth. So it looks like y to the fourth. Everybody has at least a y to the fourth, so we'll do that. So in the first term, y to the fifth divided by y to the fourth would leave y to the first power. The second term, it becomes a 1, so I won't write it. Third term, y to the eighth divided by y to the fourth leaves y to the fourth. Remember, we're subtracting the exponents when we divide. And in the last one, y to the fourth divided by y to the fourth leaves just the number 1. We won't write that. All right, on to our last, looks like we're not going to run out of room. Great, on to our last letter here. We've got p, p to the second, p, and p. So it looks like just a single p is the biggest piece they all have in common. If we divide the first term by p, it just leaves 1. Second term by p, it leaves a p. Third term by p, it leaves 1. Fourth term by p, it leaves 1. And we have our answer already. Let me just rewrite it really quickly. 5x squared, y to the fourth, p, times 7xy minus 3p plus 3x to the third, y to the fourth, plus 4. So that's our answer. And if you were to take this and multiply it through by each of these terms, you would, if we did it right, get what's up at the top there. So that's a little bit of work with finding the greatest common factor.